Now that we know about vertical and horizontal asymptotes, we should be able to graph a good amount of rational functions. We won't be able to graph everything completely accurately until we get to calculus and we can learn about derivatives and when they're equal to zero and whatever, but they probably won't give you any problems where you're not going to be able to graph them. So we're going to learn how to graph the problems that you'll most likely see in a beginning algebra class. And there's a 6-step process that is used to graph functions. You can do this in any order pretty much, except for the last two. But the first thing, let's just talk about them. The first thing to do is to find the x and y intercepts, and we do that by finding the zero of the numerator. So when the numerator is equal to 0, that's when the x value is going to be equal to 0. So when we have some function f of x is equal to n of x over d of x. So when n of x is equal to 0, that is the x-intercept, and when we put the function value in as 0, that is the y-intercept, because when x is equal to 0, then on our graph, wherever that y value is, that's where the y is. So we know about that. Next thing to do is to find the vertical asymptotes. Third thing is to find the horizontal asymptotes, if there are any. Next, we test for symmetry, and to be honest, this isn't really required, but it helps save time. That way, if we can see where the middle of this function is, or if it's on the 0, which most of the time we're going to be dealing with functions that are lined up on 0. Otherwise, it's going to be very, very difficult without calculus to make an accurate graph. So we're going to test for symmetry, which will help us in our algebra class. And then we're going to find the sign of f of x using the zeros n of x and d of x. I'll explain that when we get there. This probably doesn't make a whole lot of sense right now. What we're going to do is we're going to make a chart, and we're going to divide it up using the zeros, and we're going to find out if the function values are positive or negative, so we can know if the graph is above the x-axis or below the x-axis. It will make sense. It'll make a lot more sense to explain this using an example, and I will do that. And then after we've gotten all that information, we just graph that junk. So let's use an example. Let's say I have 2x squared minus 2 over x squared minus 9. So let's do this in order. We can do this in whatever order we feel like it. This is the order I usually do it in. The first thing to do is to find the x and y intercepts. The x-intercepts are going to be when n of x is equal to 0, and then the y-intercept is going to be when f of what the y value is when we put in f of 0. Oops. There we go. So let's find when n of x is equal to 0. So we're going to worry about this top half. So I'm going to say, let me change back. What? Whatever. 2x squared minus 2x. Oh, I see what I did. There we go. 2x squared minus 2 is equal to 0. So we want to find out when this top is equal to 0. Because when this bottom part is equal to 0, then that is a vertical asymptote. It's not included in our domain. So we want to find out when the top is equal to 0, and that's when x is going to be equal to 0. So we can factor out this 2, and then we can simplify this pretty easily. This is just x minus 1, x plus 1 is equal to 0. So this n of x value, or this function value, will be 0 when x is equal to 1 and x is equal to minus 1. So we can write that the x-intercepts are equal to minus 1 and 1. So we have that piece of information. Now let's find out where the y-intercept is. And for the y-intercept, we need to find out when, or what value the function has for f of 0. So we put in 0, so f of 0 is equal to 2 times 0 squared minus 2 over 0 squared minus 9. And this is going to give us minus 2 over minus 9, because these are going to be zeros. So this is going to be 2 over 9. So the y-intercept is equal to 2 over 9. So we've completed the first step. Let's have a look again what the second step is. Find vertical asymptotes. So one thing I'm going to do is I factored this out for finding when n of x is equal to 0. I'm going to write the top part factored out because we possibly might have a hole. Because when we factor out the denominator to figure out where x is equal to 0 for the denominator, if two of them divide out, it's not an asymptote and it's a hole. So I'm going to leave the top factored out for this example, or for this part of the problem. So I have 2 times x minus 1, and then x plus 1, and then we had x squared minus 9. And in this case, we're not going to have a hole, but it's something to look out for. That'll be some kind of trick they'll try to throw at you in one of those questions. So if we factor out the bottom, that's just x plus 3, x minus 3. So we get 2, x minus 1, x plus 1, x plus 3, x minus 3. So we can see that nothing divides out on the top and the bottom, so there are not going to be any holes. And now we're just going to look for the asymptotes, and whatever makes this denominator. So when we're looking for asymptotes, we just focus on the denominator. What's going to make this equal to 0? Well, minus 3 and 3. So we can say that the vertical asymptotes are equal to minus 3 and 3. Or we can write them out as x is equal to minus 3, like the horizontal line x is equal to minus 3. I mean, not horizontal, vertical. The vertical line x is equal to minus 3, x is equal to 3. I usually just write VA is equal to minus 3, 3. But you can write them out however you want. That's just what I personally do. So now that we've found the vertical asymptotes, we need to find the horizontal asymptotes. And there are a couple ways of doing this. As we recall, we can either use just the rules. So we have our function f of x is equal to 2x squared, it was minus 2. Minus 2 x squared minus 9. And we can either use the rules of because we can either see that both of these are the same power. We can say, well, the leading coefficient of the numerator over the leading coefficient of the denominator, and we can just divide those out, or we can just divide everything out by x squared, and either way we're going to get the same answer. I'm just going to do it this way because it's much faster, obviously, and I want to save people some time. So the leading coefficient of the numerator is 2, the leading coefficient of the denominator is 1, so this is going to be equal to 2. So we're going to have a horizontal asymptote at 2, or we can say, write it out as y is equal, the line y is equal to 2. I usually just write it out this way, as I explained earlier, but either way, doesn't really matter. do whatever you feel comfortable doing, unless you're going to do like a math paper and other people are going to read it. So now we've done vertical asymptotes, horizontal asymptotes, and zeros of the function. 4 is to test for symmetry. And we can have symmetry with respect to the y-axis or respect to the origin. So let's figure that out. So in order to test for symmetry, I'm going to have to put in minus x for this function. So I'm going to have 2 times minus x squared minus 2 over minus x squared minus 9, and this is going to be the same thing. If I put a minus x in and I get back the same thing, that means it is symmetric with the y-axis. If I had gotten the negative of it back, so if I put in minus x and I get the same thing, that means it's symmetric with respect to the y-axis. If I had put in f of minus x and it was the same as minus f of x, then this would have been symmetric with respect to the origin. We're not going to get anything with respect to the x-axis because then that is not a function. So we have these two options. Or it could be not symmetrical at all, but in which case it'll probably be a more difficult problem which would require calculus in order to give an accurate graph without just plotting a million points. So usually when we're going to be doing these algebra problems, it will be symmetric one way or the other, and it will save us a lot of time, as we're going to see, because now we have done this, we have done this, we have done this, we have done this. Now we need to find the sign of f of x using zeros of n of x and d of x. And let me explain what that means. So what I'm going to do is I'm going to make a sort of, let me use the line thing, it'll look nicer. What I'm going to do is I'm going to make a sort of chart. And I'm going to write all of my zeros on here. The things that make the numerator 0, which are the zeros of the function. So when n of x is equal to 0, these are the x-intercepts. And when d of x is equal to 0, these are the vertical asymptotes. So I'm going to need my x-intercepts and my vertical asymptotes. My x-intercepts were at minus 1 and 1, and my vertical asymptotes were at minus 3 and 3. So here, minus 3, minus 1. Actually, I can spread them out a little bit more. I got plenty of room. Minus 1, 1, and 3. And I like to write what each one is. This is a vertical asymptote. This is a 0. This is a 0. And this is a vertical asymptote. Now what we're going to do is we're going to test a point somewhere between 3 and minus infinity. And we're going to see if that is a positive value or a negative value, because we know where our vertical asymptote is now. And we're going to find a point. We want to know if this is above the x-axis or below the x-axis. So as I approach my vertical asymptote, is it going to go up? Is it going to go down? What's going to happen? So let's pick a point. Let's pick, I don't know, it could be any point. Let's just pick minus 4. Let me rewrite the function up here. So we're going to have to start plugging stuff in. So f of x is equal to 2x squared minus 2 over x squared minus 9. So I'm going to pick a point between minus infinity and 3. I'm just going to pick minus 4. So now I need to find out what the function value of minus 4 is. So f of minus 4, that's going to be, well, should I write it all out? Yeah, why not? Let me scroll down. So f minus 4, this is going to be 2 times minus 4 squared minus 2 minus 4 squared minus 9. This is going to be positive 16 times 2, that's 32, minus 2, that's 30. 16 minus 4 squared is 16, minus 9, that's 7. So we're going to get 30 over 7. So this is a positive number. I guess that's not that far below. So this is 30 over 7. So the function values are positive over here, leading up to this vertical asymptote. So the function values are going to be positive, so it's going to go, so the graph is going to look like this. It's going to come from minus infinity, and then it's going to go up, just infinitely. So now let's find a point between these two. Let's pick minus 2. So let's figure out what the sign of the function is between these values. So we have f of minus 2 is 2 times minus 2 squared minus 2 over minus 2 squared minus 9. It's minus 2, that's 4, 8. Minus 2, that's 6. And then we have 4 minus 9, so that's minus 5. So it's going to be minus 6 over 5. So we did f of minus 2, which gave us minus 6 over 5, so the sign is minus here. And let me do all of these points and let me explain to you why they are significant, because some people are going to be like, well, how do you know that this sign does not change further down the road? I'm going to explain that at the end. Let me just write it all out, I'll graph it, and then I'll explain it. And it will be more easy to understand rather than me try to build everything, an understanding out of words. I'll use pictures as well. Everyone loves pictures. So now we need one between minus 1 and 1. And if we recall, we had our y-intercept 0. So we might as well figure out what that is, and 0 is as good of a point as any. Actually, we don't even need to figure that out, because we already figured out what the y-intercept was, and that was 2 over 9. So we did our y-intercept. Our y-intercept happens to be in between minus 1 and 1, and we found out that f of 0 is equal to 2 over 9. And that's positive. And now here is the fun and useful part about symmetry, because we know that this is symmetric to the y-axis. We know that if we put in the same number over here for the minus sign, it's the same. So here's a y-axis. It's this side over here is the same as this side over here. So I know if I put in positive 2, so f of positive 2, I'm going to get the same thing over here, minus 6 over 5. And same thing for this one, positive 4. F of 4 is equal to 30 over 7. So this is going to be, oh, did I put, nah. So that was a minus, and this is going to be a positive. Because that's what symmetry to the y-intercept, or the y-axis means. Here's the y-axis. If it's symmetrical, this side is the same as this side. So here's 0. So that means if I test so if I did minus 2 over here, that means 2 is going to be the same over here. Let me do 1 really quick. I'll just do 2 really quick just to show that it is true. So here we just did minus 2. If I put in positive 2, it's going to give us the same thing, because minus 2 squared is positive 4. So it's going to give us the exact same answer. 2 squared is 4, times 2 is 8, minus 2, that's 6. 2 squared is 4, minus 9, that is minus 5, and this is also equal to minus 6 over 5. So you can see that the symmetry has eliminated half of the word for us. So that's very nice of symmetry to do that for us. So now that we have all this information, we can now graph this, and I wish there was a little bit more room. I wish I didn't put this here. Oh well. we'll just have to keep scrolling back up, which will be annoying. Yeah, I decided to erase all that crap so it would be easier to see and I didn't waste a whole bunch of time scrolling up and down. So let's get back to graphing this. The first thing I like to do is to put all of my asymptotes on. If we recall from our earlier calculation, our horizontal asymptote was equal to 2. That was the only thing that was not on this bar. So we have vertical asymptotes of minus 3 and 3. So here's minus 3. Here's 3. Here's vertical asymptote, or the horizontal asymptote of 2. So these are all of the uncrossable lines. So are lines that you do not cross in algebra. So now that we've done that, let's start using our signs to come up with our graph. So here we saw that the sign of the function was positive. So we know that this is going to approach the asymptote and go up to infinity like this. So we graphed 4 and we got 30 over 7, so 4, 30, that's like 4 and something, so that's like right here. So that's going to go up like this, up to infinity, and then it's probably going to come down something like this. So that's for that. Let's look at the next section. This is from the other side, the right side of the vertical asymptote, all the way to R0 at minus 1. Oh yeah, that's the other thing I like to do is, I almost forgot what I like to do. I like to put on my zeros as well. Or my x-intercepts, really. So here are the x-intercepts. Thought I should do that too. So we saw that the sign for the function is minus between the vertical asymptote and the 0. And here, this is what I want to explain here. A common question is, how do we know that this does not become negative over time, or when we, let me graph this. So I had minus 6 over 1, so that's minus 1 and something. So that's here, it goes to 0. So a question like this, the question someone might have is, how do I know that this does not come down? Well, first of all, there's a horizontal asymptote, but of course not every problem is going to have a horizontal asymptote. So this might be a poor example to explain this. But the reason we know that it does not cross over here, let's say there was no horizontal asymptote, this did not exist. How do I know that this does not eventually cross down into negative? Because we know there is no x-intercept. If this crosses the x-axis at some point down here, it would have an x-intercept, and it does not. The only x-intercepts we have are at minus 1 and 1. So that's how we know we can use the signs of the function, like this little graph. This is why this is true and it's reliable. But anyways, back to testing points. So the reason we know that this is true is because we've located all of our horizontal and vertical asymptotes in zeros, and so we know that it can't cross this line, obviously, and it's positive. So there's no way it's ever going to become negative, and we know this is a vertical asymptote, so the closer and closer it's going to get, it's going to go up to infinity. This is why we do this. So now between minus 1 and 1, there is a 0, so we can put in 0, and that happened to be our y-intercept, so we might as well use the y-intercept. 2 over 9, so that's somewhere right here. That's not very good. And then it's going to come back to the x-intercept. And then we saw that this was symmetrical to the other side. So it is also going to be a negative function value. So it's going to go to negative infinity as it begins to approach the asymptote. So like that. And again, because of symmetry, we know that the other side will be the exact same. So we're at 30 over 7, that's 4 something. So 4, there it is, 4 something, that's about there. And as it approaches the asymptote, it's going to go to infinity, and it's going to approach the horizontal asymptote and get closer and closer to 2. So this is the graph of the rational function f of x is equal to 2x squared minus 2 over x squared minus 9. So these are pretty work intensive. I definitely recommend coming up with a system where you do things in order, because it's very easy just to make a mistake and forget an asymptote or forget a zero. That's probably a more common mistake, is to find some zeros or find some asymptotes and then forget to include them in this I don't even know what they call it, this signs chart, I guess. That's probably the best way to describe it, the signs chart. And make sure you do the signs chart quite a few times, because that's probably the area that I would imagine that most people would have difficulty, is just getting the signs chart and then not knowing how to convert that into a graph. I suggest right away, as soon as you want to graph it, after you've done the signs chart, put the asymptotes on, the vertical and the horizontal if there is one, and then put the zeros on it, and it will be easier for you to connect the dots, so to speak. So definitely give these a lot of practice. And I'll do some more examples of these ones, and don't be intimidated if they're really long videos. These take a long time to do. So just skip through them and get what you want out of them.